So today we are going to conduct a virtual lab experiment. Had we been face to face, this is exactly something that I would have you do for yourself here in the classroom today. But we can't do that, so we'll do the next best thing. What are we studying right now? We're talking about the weather, specifically temperatures, because that's the first thing you think of when you think about what's the weather like today. Is it hot or is it cold? How hot or how cold? Well, we've had this discussion about what temperatures are. Temperatures are merely a measure of how much friction there is between moving particles. As things move around, they rub up against each other, and the more they rub, the more friction, the higher the temperature. And in this room right now, there's air moving around, and it's hitting each other. It's hitting me, causing a little bit of friction, and the amount of friction is what temperature is. Well, how do things get moving? Well, things need energy to move. And on the earth, most energy comes from the sun. Well, we're going to try to replicate that in the classroom today. What we're going to experiment with is some sand. Here's some sand that I brought back. This is actually from Oahu. This is good Hawaiian sand. We also have some water. And both of these things have a certain temperature. They're being rubbed up against and a certain amount by the air in this room. And they have about the same temperature because they're sitting in the same room. Now what I want to do is I want to change their temperature. I want to get their particles moving faster and causing more friction. Well, in order to do that, I have to give them energy. Well, if we think of outside, energy comes from the sun. Well, how are we going to replicate that here in the classroom? What I'm going to do is I'm going to use this lamp. A light bulb takes energy, and you also know that it gives off energy. That's why it gives off light. It also gives off heat. You can feel the energy coming from a light bulb. So I'm going to give some energy to my sand and give some energy to my water and see what happens. Now first, I'm going to take my digital thermometer and I'm going to measure their starting temperatures. Then I'm going to do something like this where I take a lamp and I give it some energy and I give the water some energy, and I'm going to let them sit there and soak up some energy for a certain amount of time. Usually we do about 10 minutes. And what's happening right now is this sand here in this container is getting energy from the light bulb. Well, if it's getting more energy, now these little particles of sand are going to start to move a little more. They're going to rub up against each other a little bit more, and their temperature is going to go up. Well, the same is true over here with the water. The particles of the water that are moving around in that container are now getting energy, and they're going to move faster, which means they're going to rub up against each other more, cause more friction, and the temperature will go up. So what we're going to do is compare sand versus the water. We're going to take their starting temperature, let the light shine on them for about 10 minutes each, and then see what happens. And do we notice a pattern with the temperature of the water versus the temperature of the sand? Are they the same? Because these are identical lights. They have identically powered light bulbs in there. So these samples are getting the same amount of energy, and we're going to see what the resulting change in their temperature is. So what I need you to do is to copy a chart into your notebook. This is going to be for a lab grade that when I collect your notebooks at the end of the semester, I'm going to go through and I'm going to look for this and see, and that's going to be one part of your notebook grade for the semester. So I'm going to post a picture of this. It might be backwards. I'll see what I can do. Label it Temperature Labs number 1. We're going to have 2 data charts. We're going to have a chart for the lamp being on and a chart for the lamp being off, because we're also going to take their temperatures as they're cooling down. Right now they're heating up. We're going to see how much their temperatures change when they're getting energy. Then we're going to turn the lamps off and see how much does their temperature change as they're cooling down or losing energy. So you can see we've got the sand and the water. we've got their starting temperature, and we're going to have their final temperature after 10 minutes. And we're going to subtract the two to figure out, well, how much did each one of their temperatures change? They're both going to change. They're both getting more energy. Their temperature has to go up. When we turn the lamp off, we're going to do the same thing. We're going to say, well, what temperature are they starting at? Wait 10 minutes, see how much they cool down, and figure how much their temperature changed. From that, we are going to write some conclusions together. We are also going to talk about this concept here. It's going to be a new vocabulary term called specific heat that I will go over with you at the end of the lab. And then we're going to apply this knowledge. We're going to take what we see here in the classroom and apply it to the Earth in its entirety. Well, how does what we see here apply to different places on the planet? So at this time, I need you to copy this down. And when you are finished, you're going to tell me, hey, I'm done, in the chat. And when everybody has finished this, I will give you the data. I will give you the starting temperatures and the final temperatures, and then we'll calculate the temperature change, and from that we'll fill out this section together. So at this time, start making your chart. You might have to rewind the video or pause, and when you're done, let me know, and then we'll move forward from there.